guys, with the name of God, Ram Ram. Always start everything in your life with the name of God, Ram Ram. Then no one will be able to stop you. And you will always succeed in all of your endeavors. Now guys, recently our student has cracked 50 LP off-campus SG offer from Amazon. Congratulations, you can watch her video with me here. Obviously, you can check our premium personal daily life training program link also. Now, this is a very difficult OA problem asked by Amazon, which is based on trees chain square. I ask everyone watching this video is that please watch my premium first 5 videos on trees. Okay, if you watch it only, then you will understand what now I'm going to say. So guys, they are saying that a tree is given to you. You have to divide that tree in vertical chains. Oh my god, oh my god, you have to divide that tree in vertical chains. Okay, no problem. And finally return the sum of the square of the length of the chains and make sure that the sum of the square of the length of the chains is maximized. And guys, that is a nightmare. How to maximize the sum of the length of the chains, no one knows. That's a nightmare. And was really a nightmare who was giving this Amazon OA. So it is a nightmare as long as you are not a Kumar case student. Please know that whenever you're giving these high quality online assessments, you should be having the practice of reading large English comprehensions, okay? You read them like this so you know you get some knowledge. Many people get feared just by reading these large paragraphs. No, you need to crack any online assessments, you need to have two skills in 2025. First important skill is you should be able to read large English comprehensions, okay? You should be having the ability to read large English comprehension and summarize whatever they have given in 1 to 2 lines, okay? And then after the summary you have to solve the hard unseen DSA problem given to you. So if you only do striver sheet, love bubber sheet, standard DSA sheets, forget Amazon or forget top tech company online assessment. You cannot crack it. They're asking you new question. You need to use your problem solving skills and analytical skills for it. You need to do OACP training for it. So guys, I give you a tree. They're asking you that please divide this tree in vertical chains. Okay. And they've also mentioned that root like node number 1 will be the root node of the tree. Okay. So let's say you have the tree like this. 1 to 2, 2 to 3, 3 to 4. It is a directed tree like this, guys. Directed. Okay. The chains should be broken in a directed manner. So 1 pointing to 2, 2 pointing to 3, 3 pointing to 4, 3 pointing to 5. This is the tree given to you, guys. Okay, this is the tree given to you. That's what was given, right, in the Amazon way. 1 to 2, 2 to 3, 3 to 4, 3 to 5. All react with emojis if they can feel this tree deep inside their heart without any problem. Hopefully you can feel this tree, guys. Guys, tell me which edges will you break and which chains can you make. I want you to analyze which edges you can break and which chains you can make. So someone might say, sir, I can break this edge, right? If you break this edge, guys, this is the one vertical chain you will have. This will be your first vertical chain. And then, guys, 3, 4, 5. But this is not a vertical chain, guys. Vertical chain should be vertical. See, this is coming as a V shape, right? So this is not a vertical chain, guys. This is not a vertical chain. So you need to do a breakup here also. So 3 to 4 and 5, right? So finally, if you do one more breakup, this is your second chain, and then this comes as your final chain. First chain, second chain, and third chain. First chain length is 2. So 2 square plus second chain length is 2. 2 square plus this 1 square. So 2 square plus 2 square plus 1 square. 4, 4, 8 plus 1, 9. 9 is the answer. This is one of the ways to break it in vertical chains. Guys, so I hope you understand. that node number 1 will always be the root node of the tree, and all the chains will look like this only. They will be in vertical direction only. Like if there is something like this now, then you cannot say that ABC is a vertical chain. No, ABC is not a vertical chain. Why? Because it is a directed tree. It is not following a direction. ABC can be a vertical chain only if it is having direction like this. Like this. Now this is a valid vertical chain. Can you see ABC? But this case will never happen. You don't need to worry because this is a directed tree given to you. A directed tree is given. Do you understand the meaning of directed tree? Directed tree means all the way they've given you the input, na, it will always be like this. The chains will always look like this only in the downward direction, going downward from node number 1. You can assume this thing for this particular question, okay? So guys, 9 is the answer. So guys, everyone write yes in the Google chat if they agree with this, that one of the possible ways was to break the tree like this, and one of the possible answers, okay? Guys, now tell me, is there any better way to do the breakup? Is there any better way to do the breakup so that the sum of the square of the length is even bigger than 9 in this tree? Is there any better way? Write yes or no in the Google chat. Is there any better way, guys? What is that better way, guys? What is that better way? You know one way. One way is what? Break up 2 and 3 and then break up 3 and 5. This way you know. But guys, if you do the breakup in a little bit smarter fashion, you will be saved for life, okay? So the breakup is that you will just do a single breakup of 3 to 5. Now what will happen, guys? This is one vertical chain, 1 to 2, 2 to 3 and 3 to 4, and another node is 5. See, everything is vertical chain, right? See, you cannot take the whole tree because whole tree is not vertical. Vertical chain means a single direction is there till the end, like this, or there is only one node. Now what will happen? 4 length, 4 square plus 1 square. 17 bigger than 9. 17 is the maximum answer possible, guys. Write yes, yes, yes in the Google chat if all of you have understood these things till now and you have no problem with these things. You are absolutely enjoying your life. Guys, react with love emojis if you are ready to answer for the next test case as well. So, guys, if I take the next test case, next test case in the Amazon online assessment is 1 to 2, 1 to 3, 1 to 2, 1 to 3. I hope this is it. 2 4 2 5, 2 4 2 5, 3 6 3 7. Lovely people, please tell me one thing, okay? What breakup will you do in which vertical chains so that your answer is maximized for sure? Which edges will you break? See, I can feel. I should have this one edge, right? One vertical chain, okay? Then this one vertical chain, right? So this will be 3 square, this will be 2 square, and then this node pending 1 square, this 1 square. 3 square plus 2 square plus 1 square plus 1 square. 9, 4, 13, yeah. Guys, tell me in the Google chat which edges will you break to achieve the best answer. I will break the edge 2 comma 5, 2 to 5, and then 1 to 3. I will break up, and then 3 to 6 also will break up, right? What do you guys think? Write the edges which you need to break up. 2 to 5, 1 to 3, 3 to 6. Congratulations. 2 to 5. This you need to break up. 1 2 3 you need to break up, and then 3 to 6 you need to break up. Write interesting in the Google chat if you wanted the discussion on such heavy kind of questions only. You wanted this only, right? So guys, what is the final answer after the breakup? Hopefully most of the people who are in this session, they understood. The answer is 15 now. If you break it all up, it is 3 square plus 2 square plus 1 square plus 1 square. You can see it here, right? You can see it here. Now guys, we will go into some observations. So actually the analysis in this problem is really difficult, but we will make it easy. So the my first observation, which is again very important, very important, is that it gives us a feeling that we should always go after the longest path starting at node I to calculate the best answer of subtree rooted at node I. So guys, obviously we are going to use dynamic programming on trees, okay? Guys, react with love emoji if you understand that to solve the problem. Now we are going to use DP on trees, okay? What we are going to use? DP on trees. What happens in DP on trees? In DP on trees, what happens, guys? We do bottom up traversal. We go from bottom till the top. We will first calculate answer for this part. The answer for this part will be DP of 4. Then we'll calculate answer for this part. The answer for this part will be DP of 3. Then we'll calculate answer for this part. The answer for this part will be DP of 5. Then we'll calculate answer for this part. The answer for this will be DP of 2. Then we will calculate answer for this part, which is the whole tree, beta. Which will be nothing but DP of 1 will be the final answer. DP of 1 should tell you what is the optimal way to do the breakup of the whole tree rooted at node number 1. And what is the maximum sum of length of chain square you can get. That DP of 1 will answer. It's responsibility, okay? So, guys, oh my lovely student, this much you have understood, right? And there are new people who are watching this video for the first time. Please watch my premium DSA course, first 5 tree videos. You will automatically understand what I was trying to say. Okay, guys, okay? All react with love emojis if they understood these things. Now, guys, let's try to do the analysis and let's try to get into paralysis. No, we will not go into paralysis. We will only do analysis. Okay. So guys, we know that the tree is rooted at node number 1 and all the edges are in the downward fashion only. This much you can assume. So Ram Ram, this is node number 1. Guys, here what you can do, you can take this vertical path, right? Its length will be 2 and this will give you 2 square. This will give you 1 square. This will give you 1 square. And then this subtree, if you try to calculate its answer, na, you will have to break up like this. So this will again give you 2 square and this will again give you 1 square. So what it is, in fact, it is nothing but 2 square plus 2 square plus 1 square plus 1 square plus 1 square. This is the answer. Like if you try to break up like this and you try to, this will be the answer for DP of 1, right? This is one way to break it up, okay? Guys, everyone react with love emoji if they understand that this is one way to break it up. All right, yes in the Google chat if they agree that this is just one of the ways, not the best way, but this is one of the ways. Right, yes in the Google chat, guys, if all of you agree with this. So, guys, but the theorem is the answer can always be improved by merging the small chain with a larger chain. You are breaking this edge, right? 1 to 2. There is no need to break the edge 2 to 5. Why? Because you have taken one chain as 1 to 2, another chain you have taken as 5 to 6. Rather than taking 1 to 2, 5 to 6 separately, you can just take 1 to 5 6 together, na? Then instead of 2 square plus 2 square, it will be shown as 4 square. And 4 square is strictly greater than 2 square plus 2 square. This is the mathematical proof. Congratulations. So, the theorem generally says is that smaller chains smaller chains can always be smaller chains smaller chains which can be combined with each other to give larger chain should always be combined to give maximum answer. And the mathematical proof for this is that see, if you do x plus y now, x plus y the whole square is strictly greater than if you do them separate chains, x square plus y ka whole square. You got my points, guys? You enjoyed it, right? This analysis. What I'm trying to say is that you try to break it up in any way you want, but there are some parts which can be combined, na? So you better combine them, because x plus y the whole square is nothing but x square plus y square plus 2xy. This 2xy is extra and makes the chain bigger. So if you are trying to find the best answer, it is common sense that the longest path from node number 1 will be considered in most of the cases. Though we don't have a perfect proof, but you can feel it, right? It means you need to maintain the height of each subtree rooted at node number I, which you can do by dp of I. You can just do the dynamic programming on tree, and for each node you can calculate height of tree, right? So there must be some confident student. They might say, sir, I know, sir. When the answer is nothing, sir, just height of 1, the whole square, sir. What is height of 1? 1, 2, 3, 4. No, beta ji, you also need to know that after you remove this, what happens to the other parts? And what if the tree is very big? Each part will have their separate stories. Will you just sit and cry? No. You need to be a little bit more mindful, okay? Little bit more mindful. First of all, everyone write yes in the Google chat if they understand that it is always correct to take the longest vertical path in general for a particular node, because combining those chains would anyway give you a bigger sum, right? You can also feel that earlier I was not able to prove, but after that formula and all these things, it became apparent to me that yes, this thing is actually true no matter how many trees you try. React with love emojis if till here you understood things in reality. You're not lying. Now, guys, how will you calculate the answer for a single node number 6? If the node is a leaf, what will be the answer, guys? dp of 6 is 1. Array, dp of 6 means only this node. So this will give you 1 square only, na? So we know how to calculate dp6, dp7. dp6 is 1. dp7 is also 1. DP5 is an interesting case, baby. Now listen to me carefully, my lovely student. Very important for you to listen to me very very carefully. You need to listen carefully so you are always safe. Okay. You have two options. Either you make your longest vertical path from this node or the longest vertical path from this node. So guys, there are two options for dp of phi. One option is what? You take the longest vertical path of this na. This will be nothing but what? Height of node 7. This will be nothing but what? Height of node 7 plus 1. This will be the longest vertical path na. Height of node 7 plus 1. This thing ka whole square. This thing ka whole square plus whatever happened after breaking this subtree, because anyways when the vertical path is going this way, this edge you will break. You should just need to know the best answer for the breaking way method of 6, right? So height of 7 plus 1 the whole square plus dp of 6 is one option. Another option is that rather than making 5 7 as the vertical path, you can make 5 6 as the longest vertical path. Then what it will be? Height of 6 plus 1 the current node the whole square plus the best answer for dp of phi. Now guys, you got it. Like this you will always know the answer for every node. Let's say this is the node number 1. Okay, so you have two options. The first option is your longest vertical stuff comes from here. So it is what? It is height of 3 plus 1 means this chain has been considered the whole square plus whatever the best answer was the for the sum of the squares of the subtree rooted at node number 2, which is dp of 2. This we will take maximum of this option or the second option. So guys, we have to take maximum of each child because the longest path can go from any of the child, right? Or maximum height of 2 plus 1 the whole square plus dp of 1, this thing. Okay, this thing. But even if you let's say you go through this pathway. Okay, so answer will be what? This length, so you already know very good. This length is nothing but height of 2 plus 1 the whole square plus this answer dp3. But what about these other nodes? You must be thinking na sir, but what about the answer of this? For that you need to be very careful. You actually have to add dp of 2 again, but in a very smart way. Okay, in a very smart way you have to subtract the answer. Okay, now you will think sir, what is this going, sir? Don't cry, I am there for you. मेरा कहने का मतलब क्या है कि जब नोड नंबर 1 पे इसको सिलेक्ट करते हैं ना, तो प्रॉब्लम क्या होता है? dp2 में कुछ और आंसर स्टोर है. dp2 में क्या स्टोर है बेटा? कोई बता सकता है dp2 के अंदर क्या स्टोर था? सर dp2 के अंदर स्टोर था ये वाली चेन. कितनी थी? ये चेन थी 1 2 3 3 स्क्वायर प्लस 1 स्क्वायर प्लस 1 स्क्वायर. ये स्टोर्ड है dp2 में. बट अब dp1 में लोचे क्या हो रहे हैं? dp1 में सर लोचे ये हो रहे हैं that I am following this vertical path only, but now the length has increased by 1, sir. So now it is 4 square. This I can easily get. Plus this 1 square is nothing but dp of 3, no problem. But what about the other things? You cannot just write here dp2. Why? If you write here dp2 also in this equation, it will be 3 square plus 1 square plus 1 square. But you don't want that. You actually want 4 square जो नई नई लेंथ आई है -3 स्क्वायर +1 स्क्वायर, यही तो चाहते हो ना तुम? चाहते हो ये 1 स्क्वायर ऐड हो, ये 1 स्क्वायर ऐड हो और जो 4 लेंथ लिया वो ले लो. बट पुराने टाइम का 3 स्क्वायर सर घटा दीजिएगा सर. यही चाहते हो ना, जब ये वाली वैल्यू अगर तुम इधर लिख पाओगे तब तुम्हारा काम बनेगा, राइट? Right? Yes, in the Google chat, if you can understand what complications are happening while writing this freaking formula. Do you understand the complications, bro? So, guys, what will be the final formulations? Now, I will make a particular node and I will give you C1, C2, C3, C4, C5. Make sure each one of you try to write the final answer as brilliantly as you can. Okay? All react with love emojis if they will be withholding that strength in them to do that. Also, submit in your pro groups. Okay? This is your node C1, C2, C3, C4, C5. So for DP of node, what will be the first option? First option is your longest vertical path you have selected, that it will go through C1 pathway. Okay? Okay, sir. It means rest of the edges have to be broken. So the first option is DPC2 will be there, plus DPC3 will be there, plus DPC4 will be there, plus DPC5 will be there. These things are clear. Guys, react with emojis ना if you understand. DPC to DPC3, अरे this will be there ना, because ये edges break हो गए, इसका इससे कोई रिलेशन ही नहीं है, तो जो भी इनको तोड़ने का बेस्ट तरीका था वो तो ऐड कर लिया, बस अब DPC1 को संभालना है. समझे बात को? समझे बात को? Now guys, let's assume that longest vertical path from node number C1 down is nothing but h of C1. So L is equal to h of C1. तो पहले डीपीसी वन का फॉर्मूला कैसा था? पहला डीपीसी वन का फॉर्मूला जरूर ऐसा ही रहा होगा ना, डीपीसी वन इक्वल टू हाइट ऑफ सी वन विच इज एल, एल स्क्वायर प्लस समथिंग. इट मस्ट हैव बीन समथिंग लाइक दिस, राइट? बट अभी हम क्या कर रहे हैं? हम चाहते इसको ही है, हम अभी भी इसी को चाहते हैं, बट अभी हम चाहते हैं कि इसके अंदर एल स्क्वायर की जगह एल प्लस वन स्क्वायर लग जाए. अब नोड का भी तो लेंथ ऐड हो रहा है ना. नाउ वी वांट दैट इंस्टेड ऑफ एल स्क्वायर एल प्लस वन स्क्वायर गेट्स एडेड. So earlier the sum was L square plus something. Now I want it to be L plus 1 the whole square plus that same thing. So guys, what is the difference? By how much this value is increasing? This value is only increasing by L plus 1 the whole square minus L square, which is nothing but what? L square plus 1 plus 2L minus L square, which is 2L plus 1. So the difference is only 2L plus 1. So the answer is, first option is this part plus 2 times L plus 1 plus dp of C1. So whatever was the original dp C1, na, it is now getting increased by 2L plus 1. What is L? L is h of C1, which you already have pre-calculated. This is just the first option. Right? Brilliant, brilliant, brilliant in the Google chat. If you understand that the first option means selecting a child through which you guarantee your longest vertical path will be going while calculating the answer. एक बार इसको लॉन्गेस्ट वर्टिकल पाथ बना के देख लिया, बहुत मजा आया. अब इसको लॉन्गेस्ट वर्टिकल पाथ बनाएंगे. अब इसको ऐसे करते करते सबको बना देंगे यार. Right? Brilliant, and 1,000 time love emojis in the Google chat if you have understood what's the answer for this brilliant problem. And like this, you calculate how it's increasing, so you can directly write the formula is 2L plus 1 plus DPC1. Clear? Yeah. Good job. Great job. Love you. So guys, now we will go towards the implementation. Okay. So let's go towards the brilliant implementation. Like our students keep on cracking the jobs all the time, you know that, right? So yeah, where did that go? Yeah, we have it. So guys, this is the implementation and that's what I wanted you to know. Okay, so that's it, guys. So guys, if I open up the implementation, can you see what's happening? It is really interesting phenomena, by the way. First of all, you take the input of the tree, you can see like this. They have given how to take the input of the tree. First, you do the bottom up DFS to calculate the height of each node. I hope you know how to do that, right? I taught you recently. Guys, everyone react with love emoji if they understand that the first DFS function is nothing but just calculating height of each node. See, used then for loop, and then after for loop, when the printing time comes, you just calculate the max. So h of node will automatically tell you height of node. I have pre-calculated it. That's why in the first DFS function, which I've called here, it just calculate the heights of each node. Okay. Then guys, I will calculate the DP of each node. And DP of one will be the final answer. Though I have not explicitly written DP of one in the end. Guys, this is the second DFS function. Here we assume we have the height of each node handy with us. Okay. So guys, bottom up DFS, this on upper one also was also bottom up DFS. So use node, for loop done. Very good. Now what? Now as you come below, little children, can you see? I am running two nested for loops. N square solution. Why? Because I taught you, na. I taught you one thing, right? What I taught you? This DP of node will have many options. The first option itself requires you to travel all the children, right? In the first option, what happens? You need to know the sum of dpc2 plus dpc3 till dpc5. Then in the end, you add dpc1 plus 2l plus 1. So you have to travel C1 to C5 even for the first option. Then for the second option where you consider C2 as this guy, you again need to travel all the nodes, right? In the second option, what will happen? DP C1 plus DP C3 till C5. And in the end, 2L plus 1 plus DP C2. Where 2L is nothing but height of node C2. So guys, for each node, you have to travel all the children again. So it is n square. That's why, can you see, there are two for loops. One for loop, this node, you this just make sure that we fix longest vertical path from node u. But once you have selected longest vertical path from node u, you need to travel all the other children which are not u, right? Take their dp values, and then finally your fixed longest vertical path node dp value plus 2 into height plus 1. My goodness, n squared solution. Oh my god, oh my god. Now guys, write awesome brilliant if you think this was awesome brilliant. You understood the O of n squared solution till now. This much you must have understood, right? Awesome brilliant, good, great. Sai Harsha, right? Understood. If you understood everything till now, Sai Harsha should be able to understand by now. Okay, great job, nice, awesome. So these things are clear to you people, right? Clear to everyone, right? Now, guys, react with love emoji if you are interested in knowing the optimization. Optimization is a homework and I want you to do it yourself, okay? So, guys, it is very simple. Whoever knows a prefix sum DP or a prefix sum hashing, they will easily optimize. What is happening, you know, na? What is the first option? First option is taking so much time. Why? You know that DP node, the first option is what? First option you can calculate in O of 1. Currently, we are taking O of n time. Even for the first option, we are traveling through all the nodes. You don't need to do that. First option is what? It is dpc1, which can be known in O of 1 time, plus 2 into length plus 1, which can be known in O of 1 time, plus summation of all other nodes, plus sum of all the values of dpc2 till dpc5. You are taking O of n time for this only. The sum of all the nodes of all the dp of C2 to C5 can be known in O of 1 time if you make a prefix sum array or a suffix sum array. Array pata hai na suffix sum array? I taught the suffix sum prefix sum array concept. So all the children, if you store them in an array and you calculate the sum of the dp of all the prefix and suffix, you will always have the answer, na? This sum of dpc2 to dpc5 you can get in O of 1 time using a suffix sum array. Similarly, guys, for the second option also you can calculate the answer in O of 1. What is the second option for DP node? This has been selected as the vertical path, right? So it is nothing but dpc2 plus 2l plus 1. Remember, L is nothing but height of node C2, okay? Plus the sum of this part, which is nothing but dpc1, and the sum of the nodes from C3 to C5. This you will calculate using suffix array. This you will calculate using prefix array. I know you are truly overjoyed. You learned greedy approach, DP on tree, many basics, many things. Then how to apply these techniques in these hard questions. Then how a high level mathematical formulas. Then finally prefix some dp, suffix some dp, tree dp all in one. React with love emoji if you have understood everything. And this is the final brilliant approach. Like, I'm not giving you the code directly, but you can see how I optimized. See the height function you already know. When I calculate the dp of each node, I'm storing all the children in a new array, okay, of a particular node. I'm calculating the prefix sum dp and the suffix sum dp. Now see, I only need one for loop. When I'm iterating through one child, I will know the prefix sum dp and the suffix sum dp value of all the children. Answer is nothing but current dpu plus 2 into hu plus 1 plus z. Z is nothing but the sum of the prefix and the suffix dp child. And done, 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 done. All done, okay? Guys, right? Yes, yes, in the Google chat, I will upload this code also, don't worry.